Welcome to Simultaneous Equations Level 2. Pause the video now, try the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving 3x minus y is equal to 10 and 2x plus 4y is equal to 2. Now we'd like to eliminate one of the variables, and this means we either need to get rid of the x's or get rid of the y's. But in order to do this, we need those x's or y's to have the same number in front of them, and at the moment they don't. Now looking at the two equations, it looks easiest to make the number in front of the y's the same, and we can do this by multiplying the equation at the top by 4. So if we multiply all of that equation by 4, we get 3x times 4 is 12x, minus y times 4 is minus 4y, and that's equal to 10 times 4, which is 40. And we can keep the second equation the same. And what we can now see is that because we have a minus 4y and a plus 4y in the two equations, to eliminate them, we can add the equations together, because minus 4y plus 4y is 0. So if we add everything together here, we have 12x plus 2x gives us 14x. The minus 4y and the plus 4y cancel out, and that's equal to 40 plus 2, which is 42. We can now solve this equation to find the value of x, and we can do this by dividing both sides by 14. And on the left, the times 14 and the divide by 14 cancel out to leave us with x, and on the right, 42 divided by 14 is 3. So x equals 3 is the first part of our solution. We now need to find the value of y, and we can do this by substituting our value of x into one of the two original equations, and the one that looks easiest to work with is 2x plus 4y equals 2, because this has a plus in it. If we now replace x with 3, we have 2 times 3 plus 4y equals 2, and since 2 times 3 is 6, we have 6 plus 4y is equal to 2. And we can now solve this equation, and we can start by subtracting this 6 from the left and doing the same on the right. And on the left, the 6 and the minus 6 cancel out to leave us with 4y, and on the right, 2 minus 6 is minus 4. Finally, we can remove the times 4 from in front of the y by dividing by 4 and doing the same on the other side. And on the left, the times 4 and the divide by 4 cancel out to leave us with y, and on the right, minus 4 divided by 4 is minus 1. So y is equal to minus 1. And this means that our final answer to problem 1 is x equals 3, y equals minus 1. In problem 2, we're solving 2x plus 3y equals 23 and x plus y equals 10. Now, in order to eliminate one of those variables, we need the number in front of one pair of those variables to be the same. And I'm going to make the number in front of the x's the same by multiplying the equation at the bottom by 2. And if I do this, we have 2x plus 2y is equal to 10 times 2, which is 20. And the equation at the top we can keep the same because we can now see that those x's match. So since we have a 2x in both equations, we can subtract these to eliminate them, because 2x minus 2x is 0. So starting with that, 2x minus 2x is 0, 3y minus 2y is 1y, or just y, and 23 minus 20 is 3. So we have the first part of our solution, which is that y is equal to 3. To find the value of x, we can take this value of y and substitute it into one of the two original equations, and the second one looks like the easiest one to use. So we're going to start with x plus y equals 10, and we're going to substitute in this y is equal to 3. So we have x plus 3 is equal to 10, and we can solve this now by subtracting the plus 3 on the left hand side and doing the same on the right. And on the left, the plus 3 and the minus 3 cancel out to give us x, and on the right, 10 minus 3 is 7, so x is equal to 7. And so our final answer to problem 2 is x equals 7, y equals 3. In problem 3, we're solving x plus 2y equals 20 and 5x minus y equals 1. And we want to solve this by eliminating one of the variables, so getting rid of either the x's or the y's. Now looking at the two equations, at the moment we don't have the same number in front of the x's and we don't have the same number in front of the y's. But we can multiply to make these numbers the same, which then allow us to eliminate them. So I could either multiply the equation at the top by 5 to make both equations have 5x's in them, Or I could multiply the equation at the bottom by 2 so that one equation has a 2y in it and the other has a minus 2y. I'm going to go with the second option, so I'm going to multiply the equation at the bottom by 2, and this gives me 5x times 2, which is 10x, minus y times 2 is minus 2y, and 1 times 2 is 2. And the equation at the top just remains the same. And here, because we now have a plus 2y and a minus 2y, to eliminate them, we can add the equations together, because 2y added to minus 2y makes 0. So starting with the x's, x plus 10x is 11x, the 2y and the minus 2y cancel out when we add them, and 20 plus 2 is 22. So to solve, we can remove the times 11 on the left by dividing by 11, and we need to do the same on the right. And on the left, the times 11 and the divide by 11 cancel out to leave us with x. And on the right, 22 divided by 11 is 2. So x equals 2 is the first part of our solution. To now find the value of y, we need to take this value of x and substitute it into one of the two original equations. And the easiest looking one to do this in is the first one. So I'm going to use x plus 2y is equal to 20. The second one would also be fine to use, just a bit more complicated. So if we substitute into this equation x equals 2, we have 2 plus 2y is equal to 20. We can now solve this by removing the 2 from the left, so we can subtract 2 from the left and also subtract 2 from the right. On the left, this gives us 2y, and on the right, we have equals 18. Finally, we need to remove the times 2 in front of the y, so we can divide both sides by 2, and 2y divided by 2 gives us y, and 18 divided by 2 is 9. So y is equal to 9. And this means the final answer to problem 3 is x equals 2, y equals 9.